Hey everyone, this is Gary Barnes, and today I will be going over Terraform. So, first off, what is Terraform? Well, put simply, it is a software tool or software language that allows you to deploy infrastructure with code. More specifically, it is a declarative language in the sense that let's say you have some infrastructure you want to deploy, you write the code describing the infrastructure, and then Terraform takes care of the steps to get here and leaves you with infrastructure that is up and running. Um, what's cool about this is since you are managing infrastructure with code, you can do things like version control with this, right? I know everyone watching this video would have taken Piercy's 4630 class. I don't know if he goes over much of version control, but basically it's the way in which teams can share code with each other. So maybe if you were managing infrastructure for a company, you might imagine you would have many people, managing a piece of infrastructure or managing the infrastructure that supports maybe a service or application. And what this allows them to do is collaborate on that and have the configuration you know, in a central place that everyone can see, everyone can manage, people can change and see others' changes. And what's cool, again, if you're using version control, is let's say you want to deploy, like some new infrastructure or change some infrastructure. If that doesn't work, you could roll it back to a previous version very easily by just going back to a previous version in the code, right? Using something like GitHub or GitLab. And I have used this for a few years. I was an intern at State Farm for like 4 consecutive terms, 2 summers, and then a full school year. Um, I know they used AWS, which everyone should be familiar with, to manage all of the infrastructure with their applications. Specifically, I was working on a web application, and the entirety of the infrastructure of it was AWS, right? So the front end was hosted somewhere, the API was built out using AWS Lambda, an AWS API gateway, and the database was also an AWS service. And I was able to configure all of these services using Terraform, right? So was able to sort of manually configure all of the infrastructure with this code. And what's powerful about this is, let's say, there's an outage in something like US East 1. With Terraform, it's very, very easy to create a configuration in maybe a different region automatically, right? All of these things can happen automatically. And so I'll go over a bit of an outline for this presentation. First, I'll go over some of the prerequisites you need. Then I will be going over how to deploy a single EC2 instance in Terraform. I will be going over how to deploy a web server. Um, I'll go over how to deploy a more configurable web server. So in this case, there's not a lot of hard-coded data. And then I'll go over how to deploy a cluster of servers with a load balancer. And then I will go over cleaning up. To start, there are a number of prerequisites you need. The first would be, oh, and for context, most of this, or all of this, is taken from this tutorial right here. Let's see if it will load. I've worked with Terraform quite a bit. I was trying to build some sort of outline for this presentation. I stumbled across this introduction and found that it did a much better and more concise job of going through stuff than I could have come up with on my own. And really, I think it gives a very um, great high-level overview of Terraform without going into too many of the complex stuff. So if you're more interested in this, I highly recommend checking out this blog and some of the subsequent tutorials in this same Introduction to Terraform module. So, prerequisites. First is you need to have an AWS account set up, right? So you would need to be able to access a console like this. You can see I have my own setup. I don't know if you had to do that for the 4630 class. I remember working quite a bit with AWS, so I imagine you do. I'm not sure how long this expires though after the class, but if not, they're very easy to set up. The next step would be using IAM, or Identity Access Management, creating a user for Terraform with the following permissions. Just in general, this is good practice to not be, if you're ever using like a service like this with AWS to create roles to give minimal permissions, right? You don't want to be operating as the root user with every permission. So in this case, I created this user Terraform. And if we go here, you can see I added a number of permissions, right? So apologies, my internet's a bit slow today. You can see I attached Amazon EC2 full access, IAM full access, S3 full access, CloudWatch full access, DynamoDB full access, and IAM user change password. These are just based on the recommendations of the blog. This is for the entire tutorial. I think for this one right here, you might really only need stuff like EC2. Anyways, then once you do this, what you would need to do is make sure to save the credentials of this user. So when you're setting up Terraform on the command line, you are able to export stuff like the access key and the secret access key. So after that, you would need to install Terraform. There's a page on Terraform's website right here. It's quite easy to do. You can install it manually. Just a package manager like Homebrew on iOS or just OS X. Use something like Chocolatey on Windows. And of course, there is also a way to do it on Linux. A lot of different ways to do it on Linux. So moving on, yeah, you would need to configure the AWS credentials for the user created earlier. There are lots of ways to do this, right? I think if I were to go back far enough here, I would be able to find the command I used. So I've been doing quite a bit of work in the past few days. So yeah, I mean, it would look something like this, right? You would export your AWS access key. Then this, of course, is given to you one time when you create the user, right? And doing that just allows you to set the environmental variable. So then when you install Terraform, you're able to access this. So you can check that you have Terraform by just doing something like Terraform. Oh, I have to spell it right. And something like this will come out that'll just sort of be like a output letting you know all of the commands you could use. So you could use something like Terraform version to see wherever running version 1.0.11. Great. All right, so now that we have completed those prerequisites, we can deploy a single EC2. If you took NetApps recently, you should be familiar with an EC2. It's really just a like elastic compute instance that basically lets you rent a computer from Amazon or rent a server that's pre-configured with various operating system packages, utilities, etc., and run code on them, right? You might use it to, say, host a web server or an API or something of the sort. I know we did something similar in that class. In this example, we're just going to be building a very, very basic web server, basically a basic web server. So the first thing we need to do is get an EC2 instance up and running. And of course, EC2 instance is an AWS service, so in order to do this, we need to tell Terraform that the provider we're going to be using is AWS, right? So we configure a provider. Let's use a specify provider configuration. In this case, we name it we refer to the AWS provider. There's hundreds of providers. Some other ones include like Microsoft Azure, Google Cloud, etc. And then we pass in one argument, and that the region is US East 2. We could specify any region. In this case, I'm just using US East 2. Then after that, we can create our first resource. In this case, it's going to be an instance of an EC2. So paste this code in. In general, the format is the word resource, the name of the resource, and then the name we want to give our resource, right, when we refer to it later. So again, I'm using Visual Studio Code is my text editor. There are a lot of packages for this or extensions. One is for Terraform, and in this case, it lets us hover and see something like a resource block to declares a resource of a given type. It shows us that the AWS instance is of version 3.68, and we can name it. And then, of course, the stuff we pass in here are just called arguments. And the best way to check what we need to give arguments for deploying a resource is to go over to the Terraform documentation. We could go to a provider like AWS, go down. These are all the different resources you can deploy with like AWS resources you could deploy with Terraform. Go down to EC2, look at related resources, and we'll see that AWS instance just provides us with an EC2 instance resource. So we can create it, update it, delete it, etc. Here's some example usage. In general, if you're ever using Terraform, the first place to look is always this documentation. They did a great job with it. In this case, the things we need to pass in are an AMI. Of course, we could use a default one. In this case, I'm just going to use one that I know has Ubuntu installed, a Linux distribution, and then the instance type is just, we're going to go with T2 Micro because we know that is something within the free tier and we do want to avoid being charged for this. So this is a very basic example. In this case, I can initialize Terraform in the repository I'm in with Terraform init. This will initialize the backend, and then if I do a Terraform plan, I should see the output. Of course, go here. What this shows us is that if we were to run this code, we would be creating a instance named example, right? And these are all the things that we didn't specify. A lot of these just have default values. Yeah, so that's what that shows us. So we'll see we have one resource to add, 0 to change, 0 to destroy. If we are okay with this plan, we can run a Terraform apply. And what this will do is actually create this resource. So we get output plan. We look at this plan, confirm that is what we want to do, and type in yes, and it will deploy this resource. All right, so that works successfully after giving a little bit of time. And if we go over to our AWS console for EC2, we can see that we did in fact create an instance of an EC2. You'll notice it's pretty basic, right? And doesn't even have a name. Now, of course, we could go in the console and change this, but really if we're working with Terraform, we don't want to do anything in the console. We want to either do everything using a language like Terraform or everything in the console, but mixing them gets a bit complex because then you have maybe a configuration saved in a repo somewhere that's out of sync with the actual configuration. So in order to give it a name, what we could do is use this tag attribute. And what this does is basically just in the same way that if you wanted to name an EC2 in the AWS console, you're just updating the name tag of it. Here, you're just saying for the tags, give the name Terraform example. So once again, we can run a Terraform apply, right? Or a plan first to see what will happen. So what you can see is we aren't actually adding anything or deleting anything. We're just changing a resource. In this case, we're changing the tags resource on the EC2, and we're adding name and giving it the value Terraform example. So this is in fact what I want to do. So I could run a Terraform apply. And if we give it some time, we should be able to see this change momentarily. Cool. And if we come back over to our console and refresh this, we did in fact update the name. So that's great. We created an EC2, but right now the EC2 doesn't have any sort of function, right? We're not using it for anything. So the next thing we could do is create some sort of web server. If anyone ever goes into any sort of like web development, you're going to be really familiar with this, right? We're basically just setting up a server on this EC2 that a external user could interact with. In this case, we're just going to build a simple web server that when we hit the root resource in the URL, so the URL with a / after it, it'll just return a string that says hello world. And we're doing this just with, there's a GitHub repo of like one line servers. In this case, it's a bash script that writes hello world into a file called index.html. So if again you take in Piercy's class, you'll know that when you're creating any sort of like server or website, index.html is always going to be the entry point. And then the server is going to be run on port 8080. So we know from this class, right, that an application running on a machine sort of is going to be assigned to a port. So we're going to use port 8080 at the root URL, and we're going to run it using BusyBox, which is just a utility installed on Ubuntu. So let's look at the code for that. So in this case, we're just going to be building on our previous example. So again, we have a resource, AWS instance, an example, the name's example, using the same AMI, we're using the same T2 micro. In this case, the name's here, and what we're going to do is we have this script right here, right? This is just a bash script. It writes hello world into a file called index.html. So I know, a lot of people watching this video might not be familiar with bash like scripting. This is basically taking the string, piping it into a file called index.html, and then running this command busybox that runs this on port 8080. That's the gist of this line right here. It's starting up a web server. This EOF stuff right here, this is just a way to write multi-line strings in Terraform. It's just the syntax for it, and the reason we're assigning this to the user data argument for the EC2 is this user data, anything placed in this will be run as soon as the EC2 boots up or when it first loads. In general, we would want to do something like maybe install this web server on the EC2. Right? I know in Piercy's NetApps class we went over how to do that. That is quite complicated for a tutorial this short, so in this case we're just going to add a little script that runs as soon as the instance boots, and that script will set up a very, very basic server, and then when the user tries to access that server, the entry point will be index.html that contains a string hello world, so that's what will be returned. What's important now though is if we were to boot this up, we would not be able to access this externally. So by default, there is no incoming or outgoing traffic allowed on an EC2 instance. So I know we've gone over this in the NetApps class. In order to get around this, we need to attach a security group. So we need to specify what incoming traffic is allowed and what outgoing traffic is allowed with CIDR notation, which in this class we should be quite familiar with. So if we come here, what we're going to do is create this security group, right? So it's called the AWS security group. We're going to name it instance. The name is going to be Terraform example instance, and we're going to add a rule that allows us traffic from port 8080 to port 8080, and the protocol is going to be TCP, and we're allowing this from anywhere, right? So I remember, this CIDR notation, this right here basically specifies that we can access this from any IP address. Try to add, just real quick, in order to attach the security group to this instance, we need to add this line of code. And this basically, this is a VPC security group IDs. This basically is say, hey, which security groups are we going to attach to this EC2 instance? And in this case, you can just do AWS security group .instance.id, right? So we are just grabbing this AWS security group, name instance, and attaching the ID to it. So this syntax right here just specifies this resource, and we're grabbing the ID attribute because this argument expects an ID. So we can run a Terraform plan. It's refreshing state just to check on the current configuration, and you can see we are updating a lot of stuff with this EC2. And of course it has to be replaced because we've added a lot of new stuff to it, like the user data script. Some resources that are complex, like an EC2, they won't update in place, they will just replace. And then we are adding this new security group rule down here, right? So we're adding to the new EC2 instance and the new security group. We're not changing anything, and we are destroying the old EC2 instance. So if we want to do this, we can go ahead and run a Terraform a Terraform apply. I'd run Terraform apply. So this will take a minute, but at the end of it, we'll have a new EC2 instance with this web server running on it. In this case, deployment of this resource was successful. It took a few minutes. And if we go over to our console, we can see this instance is still here. If we want to test this web server out, what we can do is we can grab this public IP address and we could enter the command in the format. You can use curl, which is a utility for maybe testing like web servers, HTTP, enter in the public IP, and then our web server is running on port 8080 based on this configuration, this configuration right here. So if we test this, we should see we get back hello world. Great. So this was cool, but the problem was this web server is not very configurable, right? We're sort of violating a principle here of not repeating yourself in code. So you can see 8080 is hard coded in a few different places, and if we were going to maybe change the port this was running on, we'd have to update the code in numerous places. In this case, we don't have to update it in 3 places, but as an application grows, we want to avoid hard coding in values like this. So we can do this with Terraform variables. So in this case, go ahead and grab an example of this. And a lot of times you wouldn't be doing all of your coding in the main file, right? You might have a file for variables, a file for inputs, file for output, file for data, and a file for each resource. But in this case, we're just doing it all in one place, so it's a little bit easier for me to show you. But declaring a variable is pretty easy, right? It's just variable, then the name of it, and description is optional, type is optional, and default is optional. A description is just a description for it. With typing, you can be pretty strict about what you can put in this variable. So for port number, we would want to use a number, and the default might be 8080. So there are a lot of different ways to pass in a variable in this, right? You could set it as an environment variable, similar to how you set like your access key for the AWS role you're using. If you were to just run a Terraform apply without specifying the variable before applying, Terraform, the command line prompt would ask you to input this variable. When you run apply, you can just pass in the variable after apply, like in a string. But in this case, we'll just set a default for 8080. And then what we can do is replace all the hard-coded points with this variable. And we can do so with the syntax, which with the word var.serverPoint, or server port, right? So var meaning variable, and then just the name of the variable. So we could come down here, var.serverport, var.serverport, and in this case, we need to replace this. Just doing var.serverport won't work because this is a string, so we can use what's called string interpolation. In this case, we would specify that it's a string, use these brackets, and then just throw in var.serverport, and this would in fact work. This would be the same as running the previous script. So that's a cool little thing. Terraform and a lot of other languages support is string interpolation, right? Putting variables into strings. And one thing we can also do is what's called grabbing an output, right? So when Terraform creates a resource, it allows people to access a lot of different information about the resource it just created. So in this case, we'll specify an output block, right? So this can either be used for creating other blocks or by just interacting, like by human consumption, right? We'll just name it public IP. The value will be AWS instance example. So right, this dot notation is the same as this right here, and then public IP is one of the many attributes that is accessible. And if you want to see more, again, you could just go to something like this documentation, and it would have a list of different resources that you could access, right? So anyways, come here, specify this output, and now when we run a Terraform apply, well, it will be spinning up the same instance, same server, and you'll see in the output that we'll have a public IP that appears. Terraform apply. We get our plan again. I'll confirm this, and then I will show you the results. So I made a small error in this user data feature right here, or attribute. I forgot this $ in the interpolated string, so now this is highlighting correctly, and it'll actually run the server on port 8080, so I should be able to run this apply now and show you the changes in a sec. This is successful, and we should be able to test this by running this curl command again, and this, of course, I cleared my console accidentally, but this is the public IP that is output after the Terraform apply is successful. Run this, great. We see that hello world is working, and the server is working. So the next thing we can do is work on deploying a cluster of servers. So the way we have this set up now is great, right? It's a working server, but you never want to use this in production because it is, we've had this discussion the past few weeks about things like scalability, reliability, managing risk, mitigating risk, right? And having a single server an application runs on in a single region is a huge single point of failure, which we want to avoid. So what we can do is deploy a cluster of servers spread off across a bunch of different availability zones that then allow us to make sure that we have like a lot more reliability. So we have a bunch of different places our server is running, and we can handle a large amount of requests. And we can do this with an AWS resource called an auto-scaling group. So the first thing we need to do, and I already have some of this code in here, is create a AWS launch configuration. In this case, it just looks very, very similar to the EC2 we created up here. We give it a name, pass in the same image ID, pass in the same instance type, pass in the same security groups. We use the same script for the user data attribute, and the only thing we're adding is this lifecycle setting called create before destroy. And basically, if we have an auto-scaling group that has a bunch of different nodes based on a configuration, if we were to change this configuration, it's saying create the new configuration before destroying the old one. And what this means is that a node and also auto-scaling group will always be pointing to some configuration, even if the configuration is out of date, maybe when we're, say, updating it. Now, once we've done this, we can create an auto-scaling group. In this case, we pass in for the launch configuration argument, we pass in this one we just created right here, right? We pass in the ID. We are saying we want minimum of 2 EC2 instances, maximum of 10. And this is just a different way of accessing the tags, which we did up here, right? Tags equal, in this case, we're adding a tag of name. Value is going to be Terraform ASG example, and propagate at launch. What this means is that every node will have this name. So the next issue is that we want to give this resource a list of availability zones to which it can be deployed in or available in, right? Just different availability zones it's allowed to exist in. We can do this with a data block, right? And I like to put my data up here. And what this is it's saying go into our AWS account or this role, grab and then just grab all of the availability zones that I have access to, right? So after we do that, we can come down here, just grab this line of code right here, and this is going under the AWS auto-scaling group. We're just going to say the availability zones, or this, we access it with data, then the name, then all, and then just grab the names, right? So this is just passing in, basically this would be an array of strings, and it's just all the availability zones we're going to deploy this in. So now we have this auto-scaling group, we need to deploy a load balancer to spread traffic between these EC2s. We can do this with the AWS Elastic Load Balancer, or ELB. There are a few different load balancers available. I think there's like, one of them is like an ALB, application load balancer, which handles HTTP traffic. There's another one that handles TCP and IP traffic. In this case, we'll just use a classic load balancer. Handles both types of traffic. It is the simplest. It's not very configurable and not very powerful. You wouldn't maybe want to use it in production, but for the purposes of this tutorial, it'll be the easiest one to get running. So what we can do is create an elastic load balancer right here. Give it a name, or sorry, right? We, signify the resource you want to create, we name it, we tie this to a specific auto-scaling group, and we also pass in the same availability zones, right? Because for each maybe node in an auto-scaling group, we want to have a load balancer in that availability zone as well, because that's how AWS handles load balancers. It's a bunch of different load balancers for each node, basically. In this case, we would then want to add a listener for incoming HTTP requests, because now the HTTP request will be hitting this elastic load balancer. So we add this. It is listening on port 80, which is the standard one for HTTP requests. Right, the protocol is HTTP because that's what we're going to be, if we're using a tool like curl, we're using HTTP. The port is going to be the port we configured earlier with a variable, and the protocol for each instance is also going to be for HTTP. So now we've set up a listener, and again, all this does, it listens for user requests and gives them to a EC2. Now we can add a sort of health check, which allows the load balancers to check on the health of these EC2 instances. So what we can also do is create a security group for this elastic load balancer. And what this allows us to do, again, we throw the name of it in right here. What this allows us to do is allow traffic out from every port. So this allows the security group to perform health checks, or the load balancer to perform health checks. We'll see what this is in a sec. And then we also allow inbound HTTP from anywhere. So in this case, it's port 80. Protocol is going to be TCP, and we're allowing this from any IP. So from port and to port 80 just shows that it is HTTP. Then we are able to attach this security group to the elastic load balancer, right? This is what we did for the EC2 a little while back. Line this lined up properly. And then the final thing we can do, or one of the last things we can do, is add a health check for the elastic load balancer. And again, make sure I know where to put this, goes right below availability zones. And basically what this does is it says the target is going to be HTTP of the server port, and every 30 seconds we're going to be checking on the web server on the EC2 and make sure it is responding within 3 seconds. And finally, we can tell the autoscaling group to register each instance with the load balancer. So go right here. And what this is saying is for the load balancer, we are using this one, right? So whenever a autoscaling group creates a new instance, it's going to register it with this elastic load balancer. And I know all of this is a bit complex. All of this stuff is coming from the documentation, right? So if you ever look at like an autoscaling group in the documentation, you'll see in the examples that you would deploy this with an elastic load balancer, and there's plenty of examples online. My point in showing you this is just that you're able to configure a bunch of different resources and get them to work with each other without having to go to the console and manually do all this. So finally, we are going to want to capture one more output. In this case, we're going to capture the DNS name of the classic load balancer, and I'll just kind of put this at the bottom where I'm putting my outputs. It's the AWS Elastic Load Balancer. Grab the name, grab the DNS name, and what this will allow us to do is actually submit those HTTP requests. So if I save all of this, I should be able to run a Terraform plan and then a Terraform apply and actually create all of these resources. Great, so as you can see, we were able to add all of these resources. I didn't delete any of the code that spins up the EC2, so we still get the output of the EC2 that's created. And we also have the DNS name of the load balancer we created. So in this case, that is right here. And what we should be able to do, it'll take a minute for all of this stuff to properly spin up. We should be able to submit a request to the classic load balancer and access the server and get hello world returned. Successful, and if we run this curl command with the output we got, we can see that this is working. And again, what's happening here is this request is hitting the load balancer, and then this load balancer is using one of the nodes we deployed in order to serve this request, right? And of course, if we come to our console here, this is under the EC2 console. We go down to load balancers and see that we have one deployed, right? Terraform ASG example. Go down to auto scaling. We deployed a launch configuration and also an auto scaling group, and we got all of these to reference each other within this code. So at this point, I think you have a pretty high level overview of, what Terraform is, how you could use it, maybe deploy a simple web server, just stuff like that. The last thing I want to show you is just how to clean everything up, right? Because we just deployed a bunch of resources. If you were doing this in the console, you'd have to go to all the different menus and manually shut everything down. What's cool is with Terraform, you could just do Terraform destroy. It'll of course ask for confirmation because this is quite a, asking. It'll go through everything we created and show you exactly what it's going to destroy and confirm this, and everything will be destroyed. So again, I hope this tutorial was useful for sort of giving you a high level overview of what Terraform is. So if maybe you see it at one of the jobs you're working in, you won't be too intimidated by it. I know a lot of corporations use stuff like this to manage their infrastructure. Or if you're working with working with AWS yourself, I find that I much prefer to work with code over clicking through a console. So for me, I much prefer this sort of approach to managing infrastructure. It's helped me learn AWS far more than working through it in the console has. And of course, a great place to start for all this would just be the Terraform website, right? There's plenty of tutorials with many different providers. A lot of cool stuff, building a Spotify playlist, fundamentals, different use cases. There's certification for it, using it in production, different integration. And also this Gruntword blog is, I found, incredibly useful for this tutorial. They have a few different books, a bunch of different guide to Terraform, and you can, even at the end, there's a lot of other stuff like how to manage state, how to create reusable infrastructure with modules. All of this is super helpful, and I think if you ever want to get into the field of DevOps, this is a phenomenal place to start. Thank you.